Examples on Fourier series of discontinuous functions. Take first example. Find Fourier series of f of x given by two equations. Minus pi if x is between minus pi to 0 and equal to x if x is between 0 to pi, and f of x plus 2 pi equal to f of x, means f of x is periodic function of period 2 pi. If graph of this function is shown, then from minus pi to 0 f of x is given by minus pi. So this straight line parallel to x-axis. If x is from 0 to pi, f of x is given by x, straight line passing through origin. Now this graph is one cycle of periodic function f of x. To find Fourier series, a0 equal to 1 by pi integration from minus pi to plus pi f of x dx. Since f of x is given in two intervals, break integration into two intervals. 1 by pi integration from minus pi to 0, and in this interval replace value of f of x equal to minus pi into dx, plus integrate 0 to pi, and in this interval replace f of x by x into dx equal to 1 by pi. Now integrate minus pi is minus pi x, and integrate x is x square by 2. Then apply limits. Replace x by upper limit and lower limit gives a0 equal to minus pi by 2. To obtain value of a suffix n equal to 1 by pi integration from minus pi to plus pi f of x into cos of nx dx, again break integration into two intervals. So 1 by pi integration from minus pi to 0, minus pi into cos of nx, plus integration 0 to pi x into cos of nx dx. Integrate first term. Integration of cos of nx is sin of nx upon n, and second term integrated by parts, integration by parts formula. So x into integrate second function sin of nx upon n minus derivative of first is 1, and again integrate this function. Integration of sin is minus cos of nx upon n square. Limits are from 0 to pi, and here limits are from minus pi to 0. Then apply limits and calculate. Sin 0 becomes 0 and sin n pi also becomes 0. Cos of n pi is minus 1 raised to n and cos 0 is 1. If these values are simplified, then calculate, gives 1 upon pi into n square in bracket minus 1 raised to n minus 1. And this value will depend on nature of n. If n is even number, then minus 1 raised to even will be plus 1. And plus 1 minus 1 becomes 0 for even values of n. If n is odd, minus 1 raised to odd is negative. Minus 1 and minus 1 becomes minus 2. So minus 2 upon pi n square if n is odd number. Then calculate similarly b suffix n. 1 by pi into integration from minus pi to plus pi f of x into sin of nx. Break integration and integrate by parts. First term integrated, minus pi constant, integrate sin of nx, minus cos of nx upon n. Limits are from minus pi to 0. Then second term integrated by parts. X into first function as it is, integrate second. Integration of sin is minus cos of nx upon n minus derivative of first 1, and again integrate this function. So minus sin of nx upon n square. Limits are from 0 to pi. Now replace x by upper limit and replace x by lower limit. Gives 1 by pi in bracket, replace x by 0. So cos 0 becomes 1. Minus 1 and minus pi is plus pi by n. Replace x by pi. So cos of minus n pi becomes cos of n pi, and this will be positive. Again subtract lower limit. In second term, replace x by pi and replace x by 0. This gives value of b suffix n. So take pi by n common, and this pi can be cancelled. 1 minus 2 minus 1 raised to n, and these values are replaced in Fourier series. So f of x is given by a0 by 2. a0 by 2 becomes minus pi by 2 upon 2 is minus pi by 4, plus a suffix n into cos of nx, and replace value of a suffix n. A suffix n is minus 2 upon pi into n square if n is odd into cos of nx, and plus replace value of b suffix n into sine of nx. Now to consider only odd values of n, we may replace n by 2n plus 1, but then summation should start from 0. So replace n by 2n plus 1, and here also n replaced by 2n plus 1, then n from 0 to infinity. So this gives Fourier series of given function.